introduction. First of all, I would like to express my sincere thanks to Axel and Raphael for organizing this very nice symposium. And I would like to talk about the asymmetric autocatalysis and origin of chirality. Yesterday, when Professor Viedma told me that when he looked into our website, he found our group members only two, myself and Dr. Kawasaki. So first I would like to show the picture of our group, about 20 people. This is myself, and he is Dr. Kawasaki in the audience, and we owe a lot Dr. Kawasaki for the achievement. And we organized the Symposium on Molecular Chirality 2007 last year, and we invited Professor Joseph Ribo to Tokyo. And I'd like to talk only about only one reaction, and because the background of the audience may be broad, let me just remind you the concept of the reaction, asymmetric reaction. I'm going to talk about the addition of alkyl metal reagent to aldehyde, R1COH. Aldehyde form, shape of aldehyde is just flat on the plane, and when the alkyl metal is polarized, alkyl is delta plus, delta minus, and metal is delta plus, and carbon is delta plus, oxygen is delta minus. When the alkyl metal approaches from the right side, called rephase, and then the carbon-carbon bond formation occurs, and after hydrolysis you will get secondary alcohol with absolute configuration. This. When R1 is phenyl, that is benzaldehyde, and methyl vinyl, you will get alcohol with R absolute configuration. And on the other hand, when the alkyl metal reagent approaches from the other side, C phase, you will get this secondary alcohol. Those are enantiomers, mirror images, and this is S. And without chiral material or chiral catalyst, the probability of the approach from the re phase and C phase is 1 to 1. When the number of molecules is very large, the ratio of S and R secondary alcohols is 1 to 1. That is the racemic. We always get racemic copper. And when we use the chiral catalyst, we can control the probability of the approach from the re phase, either or C phase. And then we can get the enantiomer-enriched secondary alcohol. That's the concept, the reaction. And as to the enantioselective addition of diethyl zinc, alkyl zinc, diethyl zinc to benzaldehyde, we have developed these chiral beta amino catalysts. That is diphenyl N-methylproinol and also N-dibutyl-norephenol. Those are highly enantioselective chiral catalysts. And when I go back, when I was still I was a graduate student at Mukayam's laboratory. That's 1979, many years ago, that we observed that in the presence of this beta amino alcohol derivative, diethyl zinc adds to benzaldehyde, and we got 1-phenylpropanol with 76% synthetic yield. But unfortunately, the E with this chiral ligand is almost zero. But still, the carbon-carbon bond formation occurs in the presence of beta amino alcohol. And then after that, Oguni and Noeri also reported, and we independently reported these chiral catalysts. And the reason that the amino alcohol accelerates the reactivity, nucleophilicity of dialkyl zinc can be explained as follows. The shape of dimethyl zinc is straight, with the bond length between zinc and carbon atoms 0.195 nanometer. When zinc atom is coordinated with other two nitrogen atoms, this is the X-ray taken from this, the bond angle carbon zinc, carbon becomes 145, bent 145 degree. At the same time, bond length between carbon and zinc atoms becomes longer, 0.198 nanometer. This means this delta minus, this means that this nucleophilicity of this methyl moiety is increased and enough to add to the carbon atom of aldehyde. And also recently, Professor Håkansson, Kyoto body, reported the X-ray crystallography of the complex of the diisopropyl zinc and TMETA. Again, so the bond and become different. We use a lot of diisopropyl zinc later. So I'm going to talk the asymmetric autocatalytic reaction. The reaction, asymmetric autocatalysis, means the structures of the chiral catalyst and the product are the same. That means the chiral product acts as a chiral catalyst for its own production with the same absolute configuration. So in other words, the process is the auto-multiplication of chiral compounds. And this type of reaction, asymmetric autocatalysis, has several advantages of the usual asymmetric catalysis.